I'm Kaylee Kreider, and it's my honor to moderate the Space Race to Save the Planet. We're hosting this panel at an extraordinary time when countries, governments, businesses all see the demand for monitoring, review, and verification just surging. Traditional measurement of methane emissions really hasn't taken place at the scale, scope, or frequency that's needed to monitor methanes at near real time. There's an urgent need to be tracking and reporting emissions, not just at the global scale, but at regional, country level, and even at the corporate level. There's now a new generation of satellites and data platforms that have emerged with extraordinary accuracy. Now these new sets of data can be used by governments, the United Nations, investors, scientists, and civil society to see and compare methane emissions and performance. With regard to transparency, it's been said that sunlight is the best disinfectant. Each of the satellites and platforms that you're going to hear about today have different capacities, capabilities, insights. Some are public, some are private. And so I'm here to introduce to you today 4 experts who have an extraordinary background and experience. So I'd like to introduce them to you today. First of all, I'm going to go from my left down the row. First of all is Dr. Steve Hamburg. I've had the joy of getting to know him just over the past year. He's the co-lead for MethaneSAT, chief scientist at the Environmental Defense Fund, and chair of science oversight for the Committee for the International Methane Emissions Observatory, or IMEO. He's also organized a groundbreaking 5-year series of 16 peer-reviewed studies documenting methane emissions at each step of the U.S. oil and gas supply chain, which found that methane emissions were at least 60% higher than official inventories. To his left, Riley Duren, CEO of the nonprofit CarbonMapper and research scientist at the University of Arizona and an engineering fellow at NASA's Jet Propulsion Laboratory, which I had a chance to meet with my former boss, Al Gore, just an extraordinary institution. Next to him, Stéphane, Germain, president of GHGSat, a company that pioneered orbital monitoring of greenhouse gases and is developing a constellation of methane-detecting satellites. And last but not least, Antoine, Rostand, president and founder of Kayrros, a data analytics company providing insight and analysis of climate and energy information from satellites and other sources. So welcome to all of you gentlemen. So happy to have you here. I was so excited to work on this panel. I had the chance to work on a satellite launch as well called Triana Discover, so I have a background in satellites myself. Took a little bit longer than we had hoped to get that one up, but it's up and running now. 3 of you are involved in satellite mission. Kayrros is a data analytics firm using data both from the European Space Agency, Tripomi satellite, and other sources. I would love for each of you to take about 5 minutes and just talk about what you're doing and how you're doing it. And then I think we'll dive into how these puzzle pieces all fit together. But I just love for you all to kind of give an overview of what it is that you're doing that just can't come across in Q&A. So I'm going to start with you, Steve, and we're going to work our way down the line. All right?
Great. Thanks so much, Kaylee. So methane is an incredibly powerful greenhouse gas, as we've been hearing, and it's really exciting to hear that here at the COP, that it's really made the main stage, both literally and figuratively. So we designed MethaneSAT to try and provide the information necessary to quantify all of the methane emissions from the oil and gas industry. We started by determining how much was being emitted and what the pattern emissions were, and then worked backwards for what kind of instrument we needed to be able to measure that from space. Working with Steve Wofsy at Harvard, we developed that, and then we went to the Smithsonian Astrophysical Observatory and said, can you build an instrument with that level of precision? Because this was it required greater precision than any satellite that was currently flying or even planned. So that's what's under construction now. It will have a the highest level of precision of any greenhouse gas emissions measuring satellite currently flying or planned at about 3 parts per billion. And what it'll be able to do is map all of the methane emissions, essentially. I mean, there is a detection threshold, but it's very low, about 5 kilograms per hour per square kilometer. So those of you who look at this, that's a darn low number. And we'll do that across all of the major oil and gas basins globally. And we will provide that data in policy relevant form in that it will include the analysis of doing the full inversion, how we convert the concentration data that the satellite is able to collect to emissions flux rates, how much is being emitted where. And that, the satellite project involved 2 major developments. One was this very high precision instrument. The second was automating inversions, which no one had done before, so that all the data will flow through this satellite, this data platform, giving us an inversion data product, and that will be for both the area emissions, a heat map, as well as for the large emitting sources, things that have roughly 500 kilograms, per hour on the map. So we will be able to see the total and how it changes over time, as well as the large emitting sources. And as you'll hear from the next 2 speakers, that's complementary to the target mode instruments that can fill in more of the point sources, because they'll be able to see more of those point sources against our background of the total emissions. Now, we'll see those emissions. We won't know where they're happening. We can put those data together. So we create something we currently don't have, and Antoine will talk about Tropomi, which does similarly, can get the total, but its detection threshold is very high, which doesn't allow us to get the granularity. So we'll have data from pixels of 100 by 400 meters. Again, folks to my left will have much smaller pixels in the target mode, and it's really the basis of a complementary ecosystem of satellites. And we believe that this approach is critical to getting the data, as I said, to ensure the transparency. All the data will be public. All the L4, that emissions data, will be free of charge. It'll take us a little while to make it really quick, but we expect to be able to release it in just a few days to a week after it's collected. We'll do the full QA/QC, the quality assurance, to have that out. So it'll come out quickly. It will be available. We'll be integrating it over time, looking for the trends that are occurring across these different geographies. And that combination, we're partnering with the New Zealand government, and they are going to use MethaneSAT data with a research effort that they've started to look at agricultural emissions across the globe. We won't be able to map everywhere. While it is a mapper, it doesn't have, it's still target mode. So we won't have the full coverage that Tropomi has, but we will be able to cover, for the first time, significant agricultural emissions with sufficient precision that we'll be able to quantify that. So, and they are going to run the Mission Operations Center in New Zealand, so they'll be the home of the operations, and we'll be constantly updating the targeting as we learn things, whether it's from other satellites and vice versa. We'll be sharing data to ensure that there's cooperation and the synergy among these satellites is maximized.
And it is, just in summary, it is interesting that Environmental Defense Fund, as far as I know, is the first nonprofit to ever be involved in launching a satellite.
I believe it is, and I forgot to mention the timeline. So we expect to be ready for launch in just about a year, is the beginning of our launch window. We don't have a specific date. We are being launched, SpaceX is our launch provider, and we'll be working as we get closer to specifically. And if those of you who follow the satellite community, just like many right now, there are COVID delays across the industry, so there's a lot of dynamic relative to when both they'll be ready with their launch and the delays in the system, because it's a ride share. They got to put them together. But certainly we will be ready, and we are very optimistic we'll be in our launch window.
Well, Riley, we'd love to hear more about CarbonMapper.
Yeah, well, thanks. Well, first I'd like to just start and reflect on where we are. I think it's extremely exciting. My group at NASA started working on greenhouse gas monitoring across different scales over a decade ago. Back in the day, we were focused on monitoring emissions at the level of nation states. Can we provide independent checks on national inventories? And then we began to zoom in. We began to focus on states and then cities. and now individual facilities and pieces of equipment. And if you'd told me 10 years ago that I'd be sitting up here with 3 other organizations that are all building what is effectively a system of systems that will do a lot of that, you could have knocked me over with a feather. There was a great story in the New York Times just recently about the Orbiting Carbon Observatory observing a trend in CO2 emissions. We worked on that satellite for years. It's taken us a decade, almost a decade to get to this point. So this is becoming real. It is real, and it's super exciting to be here. And I just want to take a second and say, yay us. CarbonMapper is both the name of a new nonprofit that we established about a year ago, and the public-private partnership we're incubating to deploy an operational system for monitoring CO2 and methane high-emitting point sources. We'll talk about that, I'm sure, a lot here in a minute, over a big chunk of the planet. And to do it very rapidly, because many of these sources are highly dynamic. They don't just emit at the same rate all the time. They're going on and off, they're variable, and so we're talking about providing daily monitoring of these sources on a regular basis, and as Steve says, to make that data publicly available for free as fast as we can reasonably do it. We have a public-private partnership that includes CarbonMapper, the NGO, Planet, the commercial space company, NASA, the state of California, the University of Arizona, Arizona State University, and RMI. And in a minute I'll talk about why we have that complex arrangement. What motivates us and what drives this program and why we felt compelled to do it, it really is on 3 different contexts. One is addressing what we perceive as an institutional and programmatic gap. It's about the challenges in deploying these systems because they're expensive. And let's be clear, right now the governments aren't paying for all of this. They're paying for some of it. So part of our motivation was to address what I would call institutional and programmatic gaps. The second point is on the idea of completeness. Is if the ultimate goal is to provide data from satellites that supports mitigation efforts, then the real figure of merit is how much of the emissions can you see for a given application, whether it's an inventory or whether it's leak detection and repair, or whether it's checking companies' commitments to meeting their decarbonization targets. The completeness, or what fraction of the total emissions you can see, fundamentally drives the architecture and design of the systems. And many satellites, what their field of view is, what their sensitivity is, etc. And the last point is data accessibility. And what I mean by that is the data transparent? Is it available where you need it, when you need it, in a format that can support decision making? One of the biggest things we've learned in our years of doing airborne surveys and providing this fine scale data to operators and regulators is there's often a gap. And those gaps can be fragmentation in jurisdiction, literally hundreds of actors. You may not know who to give the data to if they don't know to go looking for it. So there's a handoff challenge. And then there's often a technical capacity challenge on the other side. So I think a lot of what many of us are grappling with, whether it's analytics or other satellite programs or IMEO, is trying to go end to end, soup to nuts, to make the data not just available, but understandable and actionable. So those are the 3 facets that guide our program. And it's more than just the satellites, it's a program around the satellites.
Really interesting. And how long has CarbonMapper, the entity, been around? Just
about a year this month.
About a year this month.
Yeah. Mm-hmm.
Great. I thought that, but time flies. They're just like COVID time in real time. So
the NGO itself is new, but the program we've been working on for over a decade, largely on the back of NASA's research program.
Right. Yeah. Makes sense. Stéphane, we'd love to hear more about GHGSat.
Sure, thanks. So GHGSat is a commercial company that currently has 3 satellites in orbit. And we launched our first satellite in 2016. We launched 2 more in the last year. And we're offering commercial services now using those satellites to monitor facilities around the world. It's, as Steve said, it's a satellite that's really designed to look at high resolution. So seeing individual point sources, individual facilities, at the lowest possible detection threshold. So seeing the smallest possible emissions. And the purpose of that for us is to then take that data, combine it with actually aircraft data. We take the same sensor, put it on an aircraft, and combine it with third-party satellite data, so public satellite data sets, and then offer a commercial service to our customers. So customers who want to know what their own emissions are, and or governments that want to understand what the patterns of emissions are or where the large emitters are in their jurisdictions, or even third parties, analysts that are interested in understanding trends and changes in emissions around the world. So, and maybe that's a good segue into a second point I wanted to make that really is a bit different between all of us, is that really our entire mission is commercial. What we are doing is not about building satellites, it's not about advancing technology for the sake of filling holes, it's to serve an end customer need, and we designed our system from the beginning to serve that end customer need, which was about understanding the emissions that are happening today at industrial facilities around the world. You can't manage what you can't measure, right? So we are there, and it's as all of us are, working to do that. We're doing it really from a commercial point of view. So the last point I want to make is just to actually draw your attention to a snapshot that we put out just today. It's a new report that we put out today. It releases all of the emissions data we've collected over the last over 5 years now of flying our satellites. And it starts to show some pretty alarming trends. So we have seen, just in the last year, dramatic acceleration in emissions of oil and gas, methane from oil and gas, and dramatic acceleration in emissions from coal. And we can probably talk about those in a bit more detail as we go along here, but the patterns are very clear. And so for us, it's really about delivering that kind of data, bringing that kind of information to the service of the industries that emit them, being a trusted partner to them, but also being a trusted partner to governments and to any other party that wants to buy our data. Our goal is to provide that commercial service, to provide that data for anybody to use and apply in whatever way they feel they need to in order to achieve, at the end of the day, a mitigation in greenhouse gas emissions, which is really our end objective, and I think a shared objective between all of us.
And that fine resolution is really an interesting characteristic, right? It's commercial data, a fine resolution at facility level, right?
Correct.
And that's really clear, and I think helpful differentiation.
It is, and maybe that's an important point, and again, in complementarity to pick up a point that Steve was talking about earlier, we are building something that is designed really to look at individual facilities, but not necessarily on regional scales or not necessarily on global scales. To do that, you need, in our case, many, many satellites. So we have 3 in orbit now. There's 6 more that are being built as we speak, and I'm about to order another 3. So we're going to have a constellation of 10 out by the end of 2023. And so for us, having that 10 satellites enables daily coverage in key regions like the Permian Basin, for example, in the United States. So it's really having coverage either through a number of satellites or by having a satellite that's designed for coverage, revisit frequency by having a number of satellites that go back to the same place all the time, and then having that with high resolution and low detection threshold.
Let's hear more about Kayrros, and then let's dig in a little bit more, because I want to hear more about coverage, frequency, some of these other issues, but I'd love to hear more about Kayrros first.
Yeah, so I'm not a satellite guy at the beginning, I'm the bad guy, I come from the energy industry. But 12 years ago, I created an NGO to look at the technology for the energy transition, and we identify the leaks of methane as being a big threat to the energy transition because it might challenge the role of gas as a transition fuel. We have no idea on how to solve it, but at least this was clearly identified. And what we do at Kayrros is to provide to government, energy operators and investors as much data as possible on the status of energy assets. So we look at production level, at inventories, and so we've mapped all the energy assets in the world, whether producing or consuming. So we have all the cement plants in the world, the power plants, oil wells, whatever you want to, which is linked to the energy system. And when Sentinel-5P came, we said, okay, we need to crack it. And as we have a scientist that was connected to Riley and to EDF, and so we've worked a lot on Sentinel-5P to really extract value from this satellite, but using the existing understanding of the energy system, because we track activity at the well level in real time. So we had a very good prior, as we say, we had a good understanding of the system, which means that we've been able to relate the abnormal concentration that we can see in a Sentinel-5 actual assets and make sense out of what we can see with Sentinel-5. And I remember at the beginning we saw there was 2 or 3 ultra emitters a year, and when we cracked Sentinel, we found 1,000 a year. Last week there were 40 events above 10 tons per hour. 40. Yeah. So, and that was a shock, to see how much, all of that coming from coal, oil and gas, because obviously that's what basically Sentinel-5P can see, that large concentration of. We say, we need to keep on pushing for that, and obviously there is a commercial aspect with that, and we work with GHGSat to provide, a solution for the operator for them to reduce. But there is also a public good aspect of that, and like all of us, we want to contribute our data to the EMEO so that there is an understanding at government level, regulatory level, but also investors and the general public that we can see things, and everybody of us needs to act so that this practice, stops. Because releasing methane during a pipeline maintenance makes no sense. I mean, that's absurd. So we are very happy to contribute to the EMEO, and I really want to thank, Steve and the EDF for all the work they've been doing for the last 10 years to raise a flag and preach in the desert. The good thing that now the desert is populated. So.
Now you just mentioned EMEO. I understand they're trying to be a platform of platforms, essentially. Now, are all of you participating in EMEO, or most of you participating in EMEO? And just why don't you take a second and explain what that is, just in case the average viewer doesn't know what EMEO is.
I think we need to leave the chief.
Sure. So EMEO is the International Methane Emission Observatory, and the president of the European Commission described it in her talk about the methane pledge. The goal there is to bring all of these data together in a public platform and integrate them so that everyone can understand how they relate. Because we just heard they're different platforms. They'll see different aspects of the issue. And we don't have enough data with any of them to have full clarity. So the goal is, how do we bring the data together? Not just the remote sensing, which is a big piece, but also the direct measurement, the aircraft measurements that Riley talked about that he's been involved with. Also the Oil and Gas Methane Partnership 2.0, where more than 70 companies are providing voluntary data, as well as the inventories. How do we bring all that data together in a common platform that's totally open? So the UN Environment Program is leading this effort. It's a civil society effort. And it's great to have the kind of data, and Stéphane can talk about the announcement he was part of yesterday related to that, of bringing these data together. As far as I know, no effort like this has ever occurred within the greenhouse gas world, where we're bringing these many different streams together, involving data coming out of the European Union, coming out of NGO, coming out of a private sector, so that we can create a rapid response public database that tells us what's happening, where it's going, and ideally, what we all want, we're all going to push for, how it's declining over time.
Do you want to add anything to that?
I can just talk about our contribution to the IMEO. So we announced yesterday that we will be contributing all of GHGSat's data to the IMEO. And so that's our archive, and over the next 4 years, and after that, we'll talk again. But the idea is that we want to contribute to the public good as well. So the IMEO provides a unique platform where we can both do that and also maintain the commercial value of our data. So we think we can do both. We've already done that once. We already have, for example, on our website a free map of concentrations of the world. That's a combination of our data with other satellite data. And so for us, that's an important part of what we do. We are first and foremost a commercial business, but we understand that it's critical to contribute to the public good in this time when we're all trying to reduce methane emissions.
Well, it's interesting. I'd like to talk a little bit more about the capabilities of each. What is real-time, near real-time? Having been involved in the satellite world for some stretch, people don't often realize it depends upon the trajectory of the satellite, ice cover, waves, but also once it's downloaded, how long what work you need to do on the ground to map to facilities on the ground. And I'd love for you all to kind of dive in a little bit more about how that works, because you all are dealing with physics challenges, you're dealing with data challenges, other kinds of issues once you get that data. So I'd love for each of you, and maybe we'll start at your end and come back this way, to kind of talk a little bit about your capabilities, because I think we're all trying to see a little bit more like how these things fit together, and what each of you what each of these systems kind of brings to the table. And how these like puzzle pieces kind of fit together into a system-wide approach to monitoring emissions.
Okay, so I think our core capability is data fusion. So around methane, we are using Sentinel-5P, Sentinel-2, Landsat 8, but we also use Sentinel-1 for the prior. We also use wind data. And geolocation information as well to look at activity. So what we have is the data platform. We are not hardware operator, we are pure software, and we are a data fusion platform. And what we do is we put things at scale. So in terms of Sentinel-5P, we treat all the data every day. So we have almost real time as soon as the data is available. It's almost instantaneous where we have the plumes. We are working to go earlier in the treatment of the imagery, so that we probably will gain 4 or 5 days in order to have almost only 12 hours between the detection and the plume detection and the location of a plume. So, but at the end, it's an industry. Our customer, our operators, and they want something that is at scale, global, real time. As soon as the imagery is available, we treat it and we make it available to our customers through API so that they can make their own decisions. So we are not designing satellite, we are not designing sensor. We are very happy to have more sensors. What we do is we integrate them and create data that is meaningful as soon as we can.
That's really helpful, and I think that global perspective is particularly key.
Sure. So the satellites we operate are designed to be high resolution and low detection threshold. They are we launched one in 2016. That was really a pathfinder, was to demonstrate that we could do what we said we could do. Because at the time, as Riley, as you're telling the story, it was still pretty early on in doing that kind of resolution. We took everything we learned from that first one and put it into our second and third one and improved our performance by 10x.
Wow.
So that's what allows us now to have a detection threshold that's really operationally relevant. It's actionable. The oil and gas companies can use it now. And at a resolution where we can attribute and identify individual facilities, which then allows us to attribute to individual operators.
So does that, I really don't know the answer to this question. Like in the Permian, you've got almost elbow to elbow. Yeah. It's really tough there, but does that mean in even those kinds of close conditions now you're able to look
absolutely.
Facility by facility?
We can even see the difference between what part of the well pad the emission's coming from, which can be relevant because sometimes it's actually at the connection between the gathering lines and the well pad that the leak might be happening.
Oh, that's really interesting.
The resolution is enough that you can get a pretty good idea of where things are at. Well, certainly which well pad it's at and even what part of the well pad it's at. So that's critical in places like the Permian, but also in other places where there's a lot of facilities around. There's places in California where you're even tighter than elbow to elbow.
We're using good language here. I like this. This is PG language on our panel. I appreciate that.
But I do want to also emphasize that it's really important to work with other satellites and also with the algorithms and the AI combining that data, because, for example, we work really closely with the Sentinel-5P team at ESA to do what's called tipping and queuing. So Sentinel-5P sees the whole planet every day, and they'll see an enhancement here or there, and won't necessarily be able to tell because the pixels are too big exactly what's going on within that pixel. So they will tip us to go look where, to focus our high resolution sensor to find out what's going on. And we found hundreds of sources around the world that way through that kind of collaboration. It's back to the complementarity of satellites. Not every satellite can do everything, but you can combine other satellites together to do more, which then speaks to the analytics, because we also have to ingest wind data to then do inversions to figure out what the emissions rates are from the concentration patterns that we're looking at. We also combine Sentinel-2 and other satellite data measurements to be able to provide a more complete set of what's going on a daily basis worldwide. And we aim for, we could actually do a turnaround in hours from a leak that we would have seen to a measurement that we can then turn into contact an operator about. So we're not, we're bound by the limits of what Copernicus can do with the European Space Agency and Sentinel-5P. We kind of experience the same thing. There's typically a 5 to more days lag depending on how the systems are working in that particular day. But with our satellites, we really have a couple of hours and we can be there. So it's those are the kind of things that differentiate and complement each other between different satellites.
Very interesting. So when I first visited JPL, of course, with Vice President Gore, we were deeply interested in the data that you all were tracking and, wanted to know to the nth degree how soon, how fast we were going to get this information. So I'm really interested in hearing more about where you've come since the 7 years that I've been there. No, but just hearing more about the capabilities that you have now.
Yes, I would start by saying what I think should drive the capability assessment is what question are you trying to answer? There's not one methane question or application, there are many. IMEO's tackling a bunch. There are other ones that operators are tackling on their own. I mean, like Stéphane's pointing out, you get the quick detection data to an operator so they can send somebody out in the field. So it's all about just let me know something's there. It doesn't have to be quantitative so I can compare it with what's being reported to OGMP. And then there's support for what RMI and others are doing by trying to establish methane intensity standards across natural gas value chains, which is more of an accounting with multiple measurements across. So I just want to preface this by saying that if you look at this collection of questions and applications, requirements start to fall out.
And customers, right? Like who your end user, right?
Sure, but that's right. But I would also make the point that this is evolving. Right, so we're talking about applications we know about today, and about ideas that people have today. But we also try to be flexible to new things that are going to come up. All that said, what we've chose to optimize on is, like Stéphane's talking about, high spatial resolution. In our case, 30-meter pixels, and enough field of view with the instrument that without building thousands of satellites, we can get pretty good coverage. We won't approach the same kind of regional coverage as MethaneSAT, but we've designed this knowing what we think we know about where all the interesting infrastructure on the planet is today, to be able to target about 90% of what we think will be the high-emitting methane and CO2 point sources, right? So there's uncertainty in that because we don't know exactly today because we keep finding the ultra emitters out in the desert, right? So we have to make educated guesses, but this drives the design and the completeness. And so the idea behind this is to build a system that has broad enough spatial coverage that you can get the daily revisit with a finite number of satellites while having the small pixels that are key to getting the detection limit, while building an instrument that's sensitive enough that it can, it's not as sensitive as MethaneSAT, but sensitive enough to do the detection that you hit these sweet spots. Now, there are big differences in these satellites. Our satellites are not small. They're about the size of a washing machine each. So they're like the Planet SkySat satellite now. We're leveraging Planet's established constellation of, they got small satellites, they got larger satellites. And to your point about JPL, the actual sensor technology is something called imaging spectroscopy, which NASA's been developing for over 3 decades, and quite a big, public sector investment in this. And so this is the first operational use of that technology in space looking at the Earth. We've done it for decades with aircraft. We've done it on Mars, but we're going to turn that technology back and look at the Earth for decision support. And again, the last word, I want to emphasize this, it's on an operational service basis. That's a big transition here, but what we're all talking about is we're not building one-off satellites that go off and answer a science question for the first time. We're talking about capabilities that are used primarily to decide decision-making like that, as opposed to just writing science papers.
And I pick up on Riley's last point. I think for all the satellites and the analytics that we're talking about, this is that transition. Mm-hmm. It's not, we're all been involved, or at least I know 2 of us, in writing those papers and being scientists, but it's really about how do we create what I refer to as policy relevant data. And that's the real heart of this. And I want to pick up just on one thing, because I think just to sort of stretch it out and clarify it a bit. So we heard about the target mode instruments, and Riley, really great stuff. We're going to get this really large percentage of these large emitting sources. But the large emitting sources don't necessarily account for the majority of the emissions. So that if we look at oil and gas in the US, we're going to see really small sources, way, way below what any of these satellites can see as a point, represent at least half of the emissions in the US from marginal wells. And then there's another set that's in between. So that's why we need the total emissions that we can see, the target mode instruments, and when we put it together, we create the clarity of the picture that we can't do without both of those. Yep. And that's the key here, is that we can't just look at the point sources, the larger ones. They're important, particularly if we go, talk about Antoine's. These are the super emitters of the super emitters, the fat tail of the fat tail, right? These are the really big ones. Obviously, they should never occur. And a lot of these other emissions that the GHGSat and CarbonMapper will see, they shouldn't occur either. They're much more routine, but they still, and then we have all the little stuff that's happening. That shouldn't happen, and it's the collective. And so we'll be able to map that with a bunch of the point sources, then we can put on top the kind of data that we're talking about target mode, creating this bigger picture. So we'll have our data out roughly in a week. As we said, the key is you can do the sort of immediate stuff and do all that crunching, and then you got to do the putting it together with the wind and doing the full inversion, and that takes a little longer, but not a lot of time. So that near real time really matters, because now we can see what's going on. The other thing we all have to deal with is clouds. These are all passive instruments. So we won't have, and this is just one sort of reality, we won't have immediate data from any of these for everywhere in the world. There are places it's cloudy a lot. Yep. So we can't get that data that often. So for example, what we're doing in MethaneSAT is we're building a very sophisticated scheduling that actually automatically looks where are the clouds, where aren't the clouds, where are the winds, and the satellite, because we're not doing 100% wall-to-wall like Tropomi, where most of the data Tropomi gets rejected because it's got too many clouds. And so we'll be able to target and figure out, today we want to look here, we would like to look there, and then we target those places that are cloudy. We're going to keep looking every day we can. Those that aren't cloudy, we're going to get enough data, get a clear picture. If we're not seeing the intermittency, we hope, but a lot of data suggests that others have collected that it's very intermittent, we'll go back there or we'll go to somewhere else. And that's the same thing. And when we shift away from oil and gas and look at agriculture, the key there is a lot of that is diffuse emissions. And those are the things right now that none of the satellites can see. And what we'll be able to do with MethaneSAT is start to begin. We won't get it all, but we'll start to begin to map agriculture. I mean, there are some big point sources, obviously, CAFOs and some other facilities are visible to GHGSat now, but I think together. And so it's really quick data and this integration, understanding how these platforms fit together.
Can I riff off of that for a second?
Of course, yeah.
So what Steve just made a really critical point. And it come back to this idea of system of systems. There is no Swiss Army knife to solve this problem because the sources themselves are so different. So this idea this is really important, that you need different observing systems to be able to get the whole elephant. You can't just look at the tail or the trunk or the right foot or the left foot. You got to see the elephant butt and the elephant chest. You got to see the whole elephant. And though no satellite we can build in the foreseeable future will see the whole elephant, or even what we're building today, we're always going to need ground-based measurements, aircraft, and other techniques. But I think one thing that's exciting about what's happening right now is because the satellites have collectively developed sufficient skill that they offer the potential to guide action now in the near term. We may not get 99% of it in the first 5 years, but these systems are giving us insight that'll get us maybe 20, 30, 40% of the way there soon. And we feel it's better to get the knowledge now with technology we have in hand than to wait for a perfect solution. The ground-based measurements are coming, and we need more of them. And building out sensor webs and more surface-based monitoring is critical, but it will take time. Satellites have an efficiency and a rapidity, and so I think that's a key point, is it's a timing thing as much as anything.
So I hear, a couple things that I hear. First of all, there are some challenges, right? There's challenges getting measurements. There's challenges because we have a bunch of diffuse sources. There's challenges because there's no one silver bullet, right? Mm-hmm. there's challenges because you can't necessarily have ground-based measurements everywhere. Some places you're only going to have satellites. Some places you're going to be able to have ground, air, and satellites for a whole lot of considerations, from political to just geography to other pieces. There's been COVID-related delays for all sorts of reasons. I'm curious, as you look toward having impact. I think all of us have been involved in data-related measures where you put the data out there, but then it also has to be taken up. I'm curious, what has your experience been so far as you have been putting these data out there? Because even though MethaneSAT's not out there, you have been doing methane air, the rest of you have data that are out there. I would love to hear more about how has this data been landing with governments, industry, and others without reveal. You don't have to reveal the name, but I'm curious in a broader way. What's the reception been? And because I think we could all learn something from that, because I know you're not just doing data for data's sake, right? You want it to land with some impact, and you all take this however you'd like to have first. But I'd love to hear some of the feedback that you're getting now.
So I think it's we see the same trend that Stéphane was mentioning. So there was a reduction of hotspot during COVID, but now we are back at the same level in terms of frequency of events that we've seen in 2019. And it's very deceiving because, we saw that having transparency and seeing all these events, in pipeline in the US, in Russia, and in Algeria or somewhere else, there will be changes in operating procedures, and we don't see that. So transparency is really the first step, but it's not enough. Clearly, it's not enough. We push a lot with the European Commission to influence the strategy. We have been successful. So in the strategy, there is clearly the reference to satellite technology and the fact that we cannot accept ultra emitters. But it's taking a lot of time to go into legislation. Even the EPA regulation that has been published yesterday or the day before yesterday is still missing a big part of how we use satellite imagery for that. So there is, and it's normal because we have been involved in that for a long time, and the science is ready now, and we start to see some things with the first data set are now, but there is a big delay for this to translate into regulation and legislation. So I think there is a need also for the general public to be more aware of that, to realize that the energy they consume might have embedded methane or might not have, and we will need public pressure on operators for them to change their operating procedures, because it's easy to fix, but they won't change if there is no pressure.
So maybe I can, maybe I can pick up on that. We found how our data is landing now, because we're generating data now and we're providing it to customers now, is that we've gone through sort of the early stages of adoption of technology where people were very doubtful, and then they realized, oh, wait a minute, this does work. And now we're at the point where there's absolutely no doubt. It's clear, it absolutely works, and that we're getting the detection thresholds and the resolution that everybody now understands, takes for granted. In fact, it's easy now. Yeah, anybody can do it.
How long did that take from them seeing the data to them believing it? 5 years.
About 5 years. Yeah. And now we're able to fuse it with other sources of data to provide even more coverage and more visibility. So I think the hard part's not the rocket science, as fun as that is. That's not the hard part. The hard part's not the AI. That's cool too. The hard part is what you're getting at. It's the action.
Yep.
It's getting now operators and governments at different speeds to translate that into what do you do with this? And we found that with operators, it's about operationalization. It's not just about having it in an R&D department. It's about bringing into the operating teams that are really the people who drive the company. They drive the revenue. They pump the oil. They pump the gas. And they've got to be thinking on every day about what their emissions are. That's not happening yet. And at the government level, great, there's rulemaking starting or continuing, restarting, depending on the jurisdiction.
All of the above.
All of the above. And that will take time as well. But it's that part that's critical. And differentiated pricing for low carbon commodities, I think is another very important financial market tool that is just beginning to happen at RMI, for example, and other initiatives. So I think it'll take all of those.
Right, and so I want to riff off of the last two, which is, in order to do that, you need different kind of data products, because the data will come out and looks different. So if you're trying to do a carbon intensity, you need to know total emissions. You can't do it with partial emissions, and we've had this conversation, right? Because you could have a very high emissions, but not a lot of the super emitters, and you can't have no emissions and have super emitters, but you might have lower, and so you don't know that. So we have to create, and that's what we're certainly a plan at MethaneSAT, is a series of data products, all based on the data, but look different. So if you're an investor, you look at the problem one way, you look at the elephant in one way. If you're an operating company, you look at the elephant in another way. If you're a government, again, and the science community, again, different. So we're looking at building actually different data products that are based on it. They're all the same data, but that they give the information in a form that's useful to the different sectors in a more direct way, so the uptake is easier. And the good news is we've had Stéphane and others have been there already, plowing some of this ground, and we can build off of that, and Antoine and Kayrros, and the kind of aircraft-based flights that the CarbonMapper has done in California. But I think that thinking of it as not one data product, but both a series of multiple data products across different platforms, and that's where I'll just come back to IMEO. Bringing all that together is the job of IMEO. And I will put in a plug. There's a whole session on IMEO tomorrow at 1 to 2:30, and I think it's room 5, whatever, that the European Commission is putting on to really talk about how that's going to happen and how it can catalyze change.
So I'm sorry, I was laughing as you were talking. You were talking about the elephant, and I go, the science, I think the scientists are the ones walking behind the elephant with the pooper scooper. I'm afraid. Sorry, this is a bad analogy. But on the response, I would say two things. Incentives and education. Where we have shared airborne data for years and years and years, where you have a motivated actor, if they can be educated, and this is exactly the same thing. It's about 5 years, I hate to say, on average, except for some very sophisticated users. So even when the incentives are there, it can take years for the uptake to happen where it's operational. That they don't who is this and how did you get my number? They go this data is real. I don't have to prove it every time. The bigger problem is the incentives. We don't have to. I don't think we have to worry so much about the big energy companies or the carbs of the world or the agencies who already get it, who are already investing in it, who are investing in data on their own, with pilot projects. It's the rest of the universe of people who either don't have the technical capacity or the resources or the awareness to even know this exists and to even think about how they could use it. That's a large population. So I think we have to think beyond the people who are willing and get it now and just operationalizing it for them. We've got to think about how do you make this data available to people mentally, and then how do you incentivize them to act on it? Because Steve will say, this is why we're tackling oil and gas first. There are huge swaths of the methane budget that are not shovel ready, and there's work that we need to be doing today to get them ready to act on it. So that we don't come in late in the decade and start working on it. So that's a lot to chew on, but that's been my response. It's incentives and education has been the main takeaways from working with people.
I'll be lying awake at night thinking the rocket science is not the hard part. It's just going to be rattling through my mind as I
Riley solved all that
as I ponder the prod at the back of the elephant and
One of my friends at JPL says it's the socio-thermodynamics, which I think somebody should put in the dictionary. It is. That's the hard part. It's us.
Right.
Yeah. It's our institutions. That's the hard
overcoming
part.
inertia
that's the hard
is
part.
incredibly difficult.
Yeah,
right.
Absolutely.
So we have about 10 minutes left. I would love for you all to let's go through the group one last time and talk about where you think we'll be on methane with these products. I've been involved in the talks since COP2 or 3 now. And one of the big pieces that's been an issue is monitoring, review, and verification. Right? It's been everything from a holdup to a logjam to a concern to a frustration that emissions have been self-reported by countries, self-reported by companies, and just a real lack of clarity. And whether emissions we're putting on methane has been off by 30% or 60%, there's a large error bar, right? And now that we're moving toward near real-time ability to track emissions, how do you think that's going to affect proceedings like this, business pledges, forest pledges, like all of these kinds of things? How do you think that's going to affect this whole kind of ecosystem approaches of things like the NDC, the nationally determined commitments and business pledges and the rest of it? What do you think that impact is going to be, and how do you think that's going to affect your work?
Want to tell us which side to start?
I'm going to start in the middle.
All right.
So you're going to start, Riley. You're going to start. We're going to go that way and back around. How about that?
I think we're going to be. I think we're already getting ahead of the curve. The science, for once, I think is ahead of the curve on some of the policy developments. In other words, I think the data is going to be there. I don't want. I hope I'm wrong. I think the data is going to be there before we have some of the breakthroughs on the other end of the equation, which is on the incentives, the solutions, and we can't let that happen. I think there was a big announcement on Tuesday along with the Global Methane Pledge. There was a big announcement with philanthropic support, including Methane Hub, which is focused on that part of the equation, which is, let's say you've got the data, now what? That needs to happen. We're already seeing impact on the MRV front if you want to talk about the accounting use case. So we just had a great session with WMO's IGUS program with Alistair Manning from the UK, who gave the UK is now using top-down measurements from atmospheric measurements from towers. They feed directly into the process. They adjust and iterate as they need to. They're using it in an operational sense to validate and check the inventory. I think we're going to see more of that. I mean, like we just saw about OCO and what Tropomi is being able to do now at the nation level. So I think those sorts of things will put pressure on using this data on MRV front. I think more substantively is what about the parties who haven't committed yet? There are some major emitters that didn't sign up to the methane pledge. This is tricky. This MRV topic, it's particularly from space, on making emissions visible is, quite frankly sensitive. But it's important because, like you said at the beginning, a healthy dose of sunshine is probably the best thing we can do. So I think, if you ask me how I think things will change, is as more of this becomes visible and transparent and it's out there and there are no paywalls or firewalls, it's going to have an impact, right, I hope, on people coming to the table to make commitments, not just in the accounting space.
I'll just pick up on the tail end of what Riley said, which is that I routinely freak out people I talk to publicly when I say that, look, the entire planet is being monitored right now on a daily basis. Our own satellites, we've got 3 of them up, we've got another 6 that are in order, and we'll soon have 10 up, are seeing the world every day and looking for large methane emissions, and doing that with existing European Space Agency satellites. So it's there. They are monitoring the world every day. And that's only going to get better. Yep. There's only going to be more satellites with more capabilities, more complementarity. It's not going to regress, it's going to progress. So I think that what will change is that people are going to realize that more and more, that there's no getting away from it. It's there, and unless they act on it, it's going to be more and more visible. So I'm an optimist at heart, and I will say that we've had a few big wins already. It took a heck of a lot of effort, but big wins, like on a scale of a single super emitter being shut down for years, 5 megatons of carbon dioxide equivalent mitigated. And so if we can get a few of those going, a few success stories like those, there'll be a whole bunch of smaller ones. Individual companies, individual governments shutting down leaks or emissions they didn't know they had, landfills being putting gas recovery systems that didn't have them before, coal mines that have ventilated air methane systems being put in that didn't happen before. There'll be a lot of little wins, a few big wins, and I think we will get there, but it will take time. But we just need to keep plugging away at it, and I do think we are going to make a big dent in this in a matter of years, not decades.
Yep.
So I think that all this, the computing capabilities and AI has shortened the time between science and actionable data tremendously. It used to take years before scientific discovery and something that could be put into action. And Sentinel-5P was supposed to be a precursor and just for science. And in fact, a couple of months after releasing the data, we had something that was at scale, industrial, proven, and something like that. So the time to actionable data has reduced a lot, but the regulatory aspect of it has not changed. So the science to actionable data has been shortened, but not the rest. And I think we should look at what had happened during COVID. I think collectively, as mankind, we have been tremendously successful to adapt the way to look at vaccines, the way to change. We change a lot. We need to have the same kind of urgency for methane that we have for COVID, and we don't, because it is not acceptable that we can see every day this methane leak and that collectively we don't do something about it. So there is, let's learn of how we've adapted collectively as mankind to COVID, and let's change the way we make decisions, governance, how we govern this world, so that we can use this data much faster, because now we can use Sentinel-5P, we can use GHGSat, and tomorrow we'll have. But if we don't do that, you'll create nice data set and nothing will happen. Yeah. So that's my call here.
So I want to riff on all of you because I agree with much of what was said, and I think that I'm very optimistic, and I'm optimistic because I've watched over the last decade the development of the science, not just, as Riley said, not just the remote sensing, but also the other measures. There are hundreds of scientists making policy-relevant measurements now. There were very few a decade ago. So what I see is and we saw the emergence of methane this week, right? The methane pledge, it came out above. Everybody said, wow, that was all of a sudden. I said, no, there was all this work that's been going on. We're seeing that with satellites, right? We've been in the trenches for a while. We've been doing this. It's emerging. So I think in 3 years, the world will look very different, and methane will lead the way, because we will know how much is being emitted, where it's being emitted. We will have it in relevant formats with multiple communities, because right now what happens is you can dodge the data. You have income picture, you're seeing bits and pieces, and it's easy to avoid. When the picture is pretty complete, and I think we'll have in 3 years a pretty complete picture, investors will be making direct decisions because people will be putting pressure. You're investing in whom, where, what? Countries will have complete, and we won't be guessing, we won't be talking about just super emitters, we'll be talking about the total emissions.
Yep.
Are they reporting it accurately or not reporting it? I think that level of focus we've never had on a greenhouse gas problem ever. And we'll have that in 3 years. We will have collectively through the many actions. And I also think in terms of what's happening on the policy front, a lot of it's under the radar now as well. And absolutely we need the kind of commitment that's made. We need much more of that. But let's not underestimate that a lot of people have been working hard for a while to get that. And everyone here has been involved in conversations with government and various sorts. So I think collectively what we're going to see is methane become the poster child, the exemplar for dealing with greenhouse gases. We're going to have the data, it's going to be actionable across whole sectors, and I think there'll be governments will be taking a much harder look. We've seen it recently occurring at a much, much faster rate. I think everything's accelerating, so I'm looking up, but it's a lot of work to do. So I don't disagree. We're not
really,
can't coast, we got to double down.
It has the promise of taking what appears to be an invisible problem and making it visible.
Absolutely.
Which is so exciting for something that, is a precursor to air pollution, but also, a super polluting greenhouse gas. And I know for many in civil society, as well as investors and scientists, this is such an exciting time. And of course, for all of us satellite geeks, the rocket scientist crowd, it's even more exciting. But please, let's thank our panelists here for an incredible panel. I know they'll stay afterward to answer some questions, so thank you all so much.
Thank you.